Radio amateurs are very fond of getting signal reports from whichever station they work. When I started off in 1985, I did not have any S meter in the Philips Prestige home radio, which I used as a receiver for my ham radio activities along with the homebrew QRP transmitter. I used to give reports by the year like many other operators in those times. Those with commercial transceivers used to give S meter readings from their radios. Looking back, even that may not have been very accurate as many analog radios did not have a well calibrated S meter. Analog S meter or signal strength meter was a sensitive micro ammeter with a full scale deflection of 50 to 100 microamperes. In 1930s, S9 corresponded to 50 microvolts at the input terminals of the receiver. International Amateur Radio Union IARU Region 1 had brought out technical specifications for S meter readings in 1981. According to that, S9 on HF bands corresponded to minus 73 dBm. That would be 50 microvolts at the receiver's antenna input for a radio with 50 ohms input impedance. For VHF bands, S9 was defined as minus 93 dBm, which was equivalent to 5 microvolts in 50 ohms radios. A difference of 1 S unit corresponds to a 6 dB difference, which was equivalent to a voltage ratio of 2 or power ratio of 4. Signals stronger than S9 are mentioned as dB over S9, like S9 plus 20 dB. Modern software-defined radios have a more accurate S meter. Still, there could be differences between antennas of lower impedance and higher impedance. Now, what is dBm? Decibels relative to a milliwatt is mentioned as dBm. 1 watt would be 10 to the power of 3 milliwatt and hence expressed as 30 dBm. Minus 30 dBm is 0.001 milliwatt or 1 microwatt. In that way, minus 73 dBm will be 0.0501 nanowatt and minus 93 dBm 0.5 picowatt. Last two were mentioned in different units as the number of decimal points will be difficult to mention if mentioned in milliwatt. Now you can understand why extreme values are better mentioned in logarithmic unit of dB rather than with linear units. With this background information in mind, we'll have a look at the S meter in my FT710 radio. Signal strength in my VHF-UHF dual bander IC2730 is shown as segments on the LCD rather than S unit numbers. Now you can see the S meter display here. This is the S meter, the needle moving. Actually, there is no needle over there. This is just a display on the screen, digital display. Because if you connect this to an external monitor, the same display will be seen there on the external monitor as well. So this is a digital display showing an animation of a needle. And if you switch off the radio, there will be nothing seen there except the black TFT, thin film transistor screen over there. And this can be switched between various modes. In receive mode, this will be the S meter. You can see S 1, 2, 5, 7, 9. And beyond 9, you can have plus 20, plus 40, plus 60 dB. I am showing these with the mouse pointer. I have connected an external mouse to this FT710 radio. So you can see my mouse pointer moving across the S meter needle. Then the lower part is SWR. I have selected SWR, and that will be seen only during transmit mode. The same meter display is used for different functions. If you touch here, or rather click with the mouse, different functions of the same meter will be shown. That is, if you keep it as PO, then here it is displayed as power. Output power will be displayed as 0 to 150 watts, but actually this radio is only 100 watts, so it will not go beyond 100. And compressor is the COMP is the compressor level when I am using the speech processor. Then this is automatic level control, ALC. VDD will be the final amplifier drain voltage. ID is final amplifier drain current. And SWR is something which is familiar to almost all amateur radio operators. It is standing wire ratio when you connect the antenna. So in my radio, you can see that on 40 meter during even standby mode, there is high level of noise. This is not signal which you are seeing. I can't see any signal on the band now because it's early morning, nobody is there, and the band is not open. And you can see plenty of noise signals over here, and this is almost S8 noise level. Now I'll show you an interesting thing. I'll change the RF gain. Now the RF gain, I routinely keep it as almost full. If I reduce the RF gain gradually, you can see that the needle moves. See, the needle is moving upwards. Now it does 20 dB, 40 dB, 60 dB. When RF gain is reduced much, it comes to 60 dB. That means only signals beyond 59 plus 60 dB will be audible when RF gain is reduced so much. So that extra part is given to the S meter, so that when you hear a signal with RF gain low, you have to understand that the signal is very strong. I usually find this useful when I am trying to receive broadcast stations. When I receive broadcast stations, sometimes I reduce the RF gain to see what is the level of signal in the broadcast station. For routine ham radio, I don't have to reduce this. I usually keep it at full only, and actual signal strength will be displayed like this. Now it is the noise level. If I change the band, then there will be difference in noise level. If I go to 14 megahertz, this is having higher noise now, but it changes with the time of the day. And if I go to 28 megahertz, that is the band which I usually have least noise level, that is only S5 of noise. But sometimes I have lower levels of noise also. It depends on time of the day and various other parameters also. The noise level is only 5. The signal strength is actually for the noise. 21 is something in between. 18 also, the noise level is only S3. So this is the signal meter being used for assessing the noise level.